All right, folks, we have now finished our work with polynomials and factoring for the time being. So in our next chapter, we are going to be working with radicals. And we're going to learn to do all kinds of different things with radicals. We're going to learn to simplify, add, subtract, multiply, divide, pretty much the same things that we did with our polynomials. Now, radicals may not be a word that you are familiar with. So let me make sure that we know right from the start that when we talk about radicals, we are talking about roots. Okay, so you all have seen this symbol before. You all know that that is a square root. And probably also remember that when we talk about a square root, it is the opposite of squaring. So a square root undoes squaring. And you all have worked with those before. You worked with them in Algebra 1. You worked with them again in geometry. There are other types of roots as well that we will deal with. This, notice it's the same symbol but with a little 3 right here. This is a cube root. And it, of course, would be the opposite of cubing, of raising something to the third power. And you can have fourth roots and fifth roots. A fourth root would be the opposite of raising something to the fourth power. A fifth root would be the opposite of raising something to the fifth power, and so on down the line. So when you take all of these roots together, they form the group of expressions in algebra that we call radicals. So square root, cube root, fourth root, fifth root, and so on down the line. These are all examples of radicals. And notice that they undo raising a number to a power. So today we are going to work specifically with the square root. And what we want to learn how to do today is we want to learn how to simplify square roots. Now, to simplify a square root, let's start out nice and easy with this. If I ask you what is the square root of 9, keep in mind what I said before, that a square root is the opposite of squaring. When I ask you for the square root of 9, I'm saying what number times itself would give me 9 as the answer. So you all know the square root of 9 would be 3. And the reason the square root of 9 is 3 is because 3 squared is equal to 9. 3 is the number that I would have to square to get 9 as the result. If I asked you for the square root of 36, I'm saying what number times itself is 36? So you all know that would be 6. So the square root of 36 is equal to 6 because 6 squared is equal to 36. So a square root asks the question, what number times itself will give this result? If I wanted the square root of 100, what number times itself is 100? You all know that would be 10. So the square root of 100 is 10 because 10 squared is equal to 100. All right, so that kind of gives us a brief rundown of square roots. When you see a square root, it's asking what question or what number times itself will give this result that you want underneath the square root symbol. All right, so now let's suppose that I ask you to do something like the square root of 8. So that would be saying what number times itself would give me 8 as the result. Now what you'll notice is this time we can't answer that question because there is no whole number that we can multiply times itself and get 8 as the result. So this right now for us would be a question mark. This is where simplifying square roots comes into play. When you are asked to simplify a square root, what they want you to do is they want you to make the number underneath the square root as small as possible. Make the number underneath the square root as small as possible. Now here's how we're going to do that. We are going to simplify the square root of 8 by factoring it. So here's what we're going to do. We're going to find two numbers that multiply to give us 8, where one of the numbers is a perfect square. So we're going to find two numbers that multiply to give us 8, where one of those two numbers is a perfect square. Now I want you to remember what perfect squares are. We talked about this when we were doing a difference of squares. A perfect square is the result of multiplying a number times itself. So 9 and 36 and 100 are all examples of perfect squares. So if we think about those, let me make myself a little space right here. To get a list of perfect squares, I could just start at the number 1 and start squaring things, okay? So I know 1 squared would be 1, and 2 squared would be 4, and 3 squared would be 9, and 4 squared would be 16, and 5 squared would be 25, and 6 squared would be 36, and 7 squared would be 49, and I could continue on and on. But I think I've done enough of the list that we can do what we're being asked to do here. We're being asked to find two numbers that multiply to give us 8, where one of the numbers is a perfect square. So if I come up here and I look at my list, I know that if I use the number 4, I can find factors that will give me 8. So I know that 8 is 4 times 2. So I'm going to come over here and I'm going to rewrite the square root of 8 as the square root of 4 times the square root of 2. So notice I've taken the 8 and I've split it up so that one number is a perfect square while the other is not. So this first one is something I can do, and the second one is something that I can't do the square root of. So you're going to hear me talk about that a lot. When you need to simplify a square root where your number is not a perfect square, you are going to split it up into two radicals. The first one is something you can take the square root of, so it's got to be a perfect square, and the second number will be something that you can't take the square root of. All right, so now here's how we finish this. All right, the square root of 8 becomes the square root of 4 times the square root of 2. This is asking me what number times itself is 4. I know the answer to that. I can do that. That is 2. This is asking me what number times itself is 2. I can't do that, so I leave it alone. So I do this part, the square root of 4 is 2, and I don't do this part because I can't. So 2 root 2 would be the simplified version for the square root of 8. This is the answer that I would give. Now, normally when we see this word simplify, simplify means that it's going to be simpler. I don't know about you, but I don't think this looks simpler than the square root of 8, but it all goes back to what I said up here. Our goal is to make the number underneath the square root as small as possible. So we had an 8 underneath the square root, and we have reduced that down to a 2. So simplifying a square root is sometimes referred to as reducing the square root. And reducing kind of drives home that fact that you're trying to make the number that's under the square root as small as possible. So to kind of recap what we've said so far, a square root is the opposite of squaring. So it's asking what number times itself would give this result. As long as your number is a perfect square, they're going to be easy to do. But when you're asked to do the square root of something like 8, that is not a perfect square, then you are going to simplify it, reduce it, by finding two numbers that will multiply to give you that result. One of those two numbers has to be a perfect square. Has to be. So we would take 8 and make it the square root of 4 times the square root of 2. Square root of 4 is 2. The square root of 2 we don't know, so that would give me my final answer. Now, before we go any further into this lesson then, I think you can see how important your perfect squares are going to be. So I want you to get a clean sheet of paper. And we're going to make a list of some perfect squares. I want you to make sure on this sheet of paper on this list that the perfect squares are all you have on here. So don't write any notes, don't put any examples, anything like that, because if your sheet is just a list of perfect squares and doesn't have any notes or examples on it, then you will be allowed to use it for your tests and quizzes. So here's what we're going to do. We're going to start out with 1, and we're going to do 1 squared. We know that's 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared, excuse me, is 289. 18 squared is 324. 19 squared, that one has left me for just a minute. 361. 20 squared is 400. 21 squared, we're almost done, I promise, is 441. 22 squared is 484. 23 squared is 529. Oh, shoot. 529. 24 squared is, I think 576. Yes, that's right, 576. 25 squared is 625. And then 26 squared is 676. Okay, now that's where we're going to stop. If you needed to add to this list later on, you certainly could, but this is the list we're going to use. Because keep in mind that to simplify a square root, we are going to have to rewrite it in factored form using two numbers, and one of those numbers has to be in this list. So make this list and keep it close by. All right, so now let's do some examples where I show you how to simplify some square roots. Listen really carefully, and certainly after you watch the video, if there are questions, you can let me know. Now, one of the things that I should say is that when you are simplifying a square root, your goal is to get the biggest number from this list, that the biggest perfect square that your number is divisible by. So if I'm thinking about the number 50, my goal is to get the biggest number from this list that 50 will divide by. So, you know, right here's about where 50 would fall. I know 50 won't divide by 49. It won't divide by 36. It will, however, divide by 25. So to simplify the square root of 50, 25 is the perfect square that I need to use. So notice what I did there. I started out in my list where 50 would fall, and then I worked my way up. You want to do that to make sure you get the biggest perfect square that is a factor of your number. So 25 is the number that I'm going to use to help me simplify this. So I'm going to rewrite the square root of 50 as a multiplication problem. One of my two numbers has to be a perfect square, and I have decided that 25 is the number I need to use. It takes 25 times 2 to get 50. So I'm going to rewrite the square root of 50 as the square root of 25 times 2. I find the biggest number from the perfect square list, that is a factor of 50, and then use whatever I need to use here to finish it off. All right, now, square root of 25 means what number times itself is 25. I know that. I can do that. That is 5. The square root of 2 means what number times itself is 2. I have no idea. So I can't do that. So notice, I can do the square root of 25. That gives me 5. I can't do the square root of 2, so I leave it as is. And 5 times the square root of 2 would be my answer. So all of these are going to have to break down into two numbers. One number has to be from the list, and it needs to be the biggest number, and then the other number is not in the list. So that's how this will go every single time. All right, so now let's try the square root of 27. The square root of 27. That means what number times itself is 27. And there isn't an answer for that. So we're going to simplify this by splitting it into two square roots. So here is where I would go to my list. 27 would fall right here between 25 and 36. So I want to find the biggest number in this list that is a factor of 27. 27 won't divide by 25 or by 16, but 25 or 27 will divide by 9. So I think 9 is my number from the list that I need to use to factor this 27. So I'm going to rewrite the square root of 27 as the square root of 9. So there's my list number times the square root of 3. The square root of 9 means what number times itself is 9. I know that's 3. And then what number times itself is 3? We have no idea, so we leave that alone. So notice again how the first radical, which is your number from the list, you will be able to do. The second one you won't be able to do. So you'll have a can do radical and a can't do radical every single time. All right, let's do the square root of 48. Let's do the square root of 48. What number times itself is 48? There is no number, no whole number that will do that. So we're going to do the same thing. We're going to split it into two square roots. So 48 would fall right here between 36 and 49. So I need to see which one of these numbers above that 49 is a factor of 48. And I want to use the biggest one. So 48 won't divide by 36. It won't divide by 25. 48 will divide by 16. I want you to notice 48 will also divide by 4. 4 times 12, let me write that here. 4 times 12 would give me 48, and 16 times 3 will give me 48. You always want to use the bigger perfect square. So the 16 times 3 is the option that we should go with. So that's why when you know you're dealing with 48, I suggest you go to where 48 would be in the list, which is right here, and then work your way up. Because that way you'll make sure you get that biggest number first. So 16 times 3 is the way that I'm going to want to work with this 48. So I'm going to rewrite this as the square root of 16 times the square root of 3. One of the numbers, though, has to come from that list. All right, so what number times itself is 16? That should be 4. What number times itself is 3? I don't know. So I leave that part alone. So 4 root 3 would be my answer. All right, let's do the square root of 72. All right, I need to factor my 72 into two square roots. One of the numbers that I use has to come from my perfect squares list. So 72 would fall right here between 64 and 81. So I need to see which of these numbers above 81 will work. 72 will not divide by 64, so that's not a factor. It won't divide by 49. Will 72 divide by 36? I believe it will. 72 is 36 times 2. So there's what I want to use. I'm going to come back over here and I'm going to rewrite this as the square root of 36 times the square root of 2. And let me just say there, if you don't know whether 72 will divide by 36 or not, or any of those other numbers, use your calculator to find out. But keep in mind and always remember that you need to start at the perfect square that's closest to 72 and work your way up through the list so you are guaranteed that you will get that largest number. So what number times itself is 36? That, of course, is 6. What number times itself is 2? We don't know, so we leave that alone. So simplified version for the square root of 72 would be 6 square roots of 2. Hopefully this is making sense. So on every single one of these, we're factoring the number into two parts. One of those parts has to be a perfect square. It's got to come from the list, and it needs to be the biggest number in that list. And then the second number will be whatever's left over. Okay, so now let's try simplifying the square root of 192. Okay, so I'm going to have to factor it into two numbers, and to help me do that, I'm going to go to my list. All right, 192 falls right here between 169 and 196. So I need to see which of these numbers above 192 would be a factor, because I want the biggest one. So I can try 192 divided by 169. That's not going to work. I can try 192 divided by 144. That won't work. 192 divided by 121. by 100, by 81. The first time that I run into a situation where this will work is when I do 192 divided by 64. When I do 192 divided by 64, I get 3. So 64 times 3 is 192. So right there's the combination I want to use. So 64, square root of 64 times square root of 3. So what number times itself is 64? That's an 8. What number times itself is 3? We don't know. So 8 square roots of 3, 8 root 3 would be the answer for that. Okay, now I've got just a couple more problems that I want to show you here. And I want to show you these because not only are you going to have your square root, there's going to be a number sitting out here already. So in this problem, I'm trying to simplify 8 square roots of 63. So when you do that, what's going to happen is this 8, you're just going to leave alone for the moment. He's going to hang out there and wait on you to simplify the square root of 63. So the first thing you're going to do is you're going to think of this thing as 8 times the square root of 63. And then what you'll do is you'll take the square root of 63 and do with it what we've been doing. You're going to split it into its factors so that one of them is a perfect square. So if I'm looking for the square root of 63, when I go to my list, 63 would fall right here. I know 63 won't divide by 49. It won't divide by 36. It won't divide by 25. It won't divide by 16. It will, however, divide by 9. 9 times 7, I know, is 63. So I'll head back over here now and I'll take my square root of 63 and make it the square root of 9 times the square root of 7. Now, this 8, again, just going to wait on me. What number times itself is 9? That would be a 3. What number times itself is 7? Have no idea. So I have 8 times 3 times the square root of 7. I can go ahead and multiply the 8 times the 3 and get 24. So 24 square roots of 7 would be the simplified version. So notice that 8 that's outside of the square root just kind of hangs out and waits on you until you get the square root of 63 simplified. All right, let's do one more like that, and then I think we should be all set on this lesson. All right, for this last example, we are going to simplify 5 square roots of 150. So we know that is 5 times the square root of 150. And then we're going to take the square root of 150 and factor it so that one of these numbers is a perfect square. All right, so back to my list. All right, 150 would be right here between 144 and 169. So I want to work my way up and find the biggest number that 150 will divide by. 150 won't divide by 144 or 121 or 100 or 81 or 64 or 49 or 36, but I know 150 will divide by 25. So that's the number I need to use. So going back over here to my problem, I'm going to take 150, the square root of 150, and break that down into the square root of 25 times the square root of 6. 25 times 6 will get me 150. Now again, the 5 is just hanging out waiting on me. The square root of 25 means what number times itself is 25. I know that's 5. And then the square root of 6 means what number times itself is 6. I don't have any idea what that is. So now I have 5 times the square root of 6. And to finish this off, I can multiply the 5 times the 5, which makes that number outside of 25. So 25 square roots of 6 will be my final answer. So when you are simplifying the square root of a number, your goal is to factor it into 2 roots. One of these needs to be a perfect square, and it needs to be the largest perfect square from your list, okay? And then over here you'll have whatever number it takes. So this has got to be a perfect square, it's got to come from the list, and it needs to be the largest number from the list. All right, so you've got a few problems to try on this today. Tomorrow we're going to add variables to it. If you have questions about what you've seen today, I will be checking my email often throughout the day, so let me know. Let me know if you need me.